They believed perfection would win the war. Every bolt exact, every repair flawless. But when the battlefield began to move faster than their doctrine, precision became a trap, and speed decided who survived. German military maintenance doctrine during the Second World War was not simply a technical framework. It was a belief system. Precision was treated not merely as a requirement, but as proof of superiority and discipline. From engines to optics, from transmissions to firing mechanisms, German equipment was designed to operate within narrow tolerances, and maintenance philosophy assumed that those tolerances must always be restored. A machine was either correct or it was unfit for service. There was little conceptual space for temporary, improvised, or good enough. This mindset was reinforced long before the war began, rooted in interwar engineering culture, institutional pride, and a deep confidence in technical mastery. Workshops were expected to mirror factories. Repairs were meant to return machines to near original condition, not merely functional status. In the early years of the war, this doctrine appeared justified. German forces advanced rapidly across Europe, supported by relatively short supply lines and controlled rear areas. Maintenance units had time, space, and access to specialized tools and trained technicians. Damaged vehicles could be recovered, transported, and repaired methodically without pressure from collapsing fronts. Precision worked because the battlefield still allowed order. Each successful campaign reinforced the assumption that technical excellence naturally translated into operational dominance. Precision became synonymous with reliability, and reliability with victory itself. But embedded within this doctrine was a critical assumption that went largely unexamined: that war would continue to provide the conditions necessary for precision to exist. German maintenance systems were centralized, hierarchical, and dependent on specialized personnel. Complex machines required expert attention. Spare parts were specific, often non-interchangeable, and produced to exact specifications. If a component was unavailable, the repair did not proceed. Cannibalization occurred, but it was considered a last resort, not a routine solution. The goal was preservation of quality, even at the cost of time, availability, and momentum. As the war expanded and conditions deteriorated, this assumption became increasingly fragile. Fronts lengthened across multiple theaters. Supply lines stretched beyond their design limits. Allied bombing campaigns disrupted transportation hubs, factories, and rail networks. Workshops were forced closer to the front or destroyed entirely. Yet doctrine did not fundamentally change. Precision remained the priority, even as the environment that supported it collapsed. A tank immobilized by a minor mechanical fault might be withdrawn for days or weeks, awaiting the correct part, while the front moved on without it. The machine remained technically sound in theory, but operationally absent in reality. This rigidity was not born of incompetence, but of institutional inertia. German training systems produced mechanics skilled in exact procedures, not improvisation under pressure. Deviating from prescribed standards was seen as dangerous, unprofessional, even irresponsible. Commanders trusted the doctrine because it had worked before. Admitting its limits meant admitting that the foundation of German technical superiority was conditional, not absolute. By contrast, the battlefield of 1944 no longer rewarded conditional systems. War had become fluid, chaotic, and brutally time-sensitive. The belief that precision could be preserved under any circumstances began to fail. Not all at once, but incrementally. Each delayed repair, each abandoned vehicle, each workshop overrun by advancing enemy forces chipped away at a doctrine that had never been designed to bend. This was the moment when precision stopped being a strength and began to reveal itself as a constraint. The war was changing faster than doctrine could adapt, and the cost of that delay would soon become unmistakable. Welcome to WW2 Forgotten Fronts. where the untold battles, hidden heroes, and overlooked machines of World War II finally come to light. Here, we uncover the stories history left behind, the frontline diaries, the lost operations, and the moments of courage that shaped the world, yet rarely appear in textbooks. If you enjoy deep storytelling, cinematic narration, and forgotten perspectives from the war, you're in the right place. Make sure to subscribe, leave a like, and share this video. Your support helps this channel continue bringing these forgotten chapters of history back to life. Now, let's step into the past. American military maintenance doctrine during the Second World War was shaped by a very different assumption about how wars were actually fought. Instead of treating precision as a principle to be preserved at all costs, American planners treated time as the most valuable resource on the battlefield. Equipment was expected to fail. Repairs were expected to be imperfect. The system was designed not to prevent breakdowns entirely, but to recover from them faster than the enemy could exploit them. In this logic, a vehicle that could still move, fire, or transport supplies, even at reduced performance, was more valuable than a flawless machine sitting idle behind the lines. This mindset influenced equipment design from the beginning. American vehicles emphasized modular components, standardized parts, and mechanical accessibility. Engines could be swapped rather than rebuilt. Components were shared across different vehicle types, reducing dependency on specialized spare parts. Tolerances were looser, not because American engineers lacked skill, but because they understood that field conditions would never resemble factories. Dirt, mud, cold, heat, and combat damage were treated as constants, not exceptions. Maintenance doctrine accepted that field repairs would often be crude, temporary, and visibly imperfect. Crucially, American doctrine decentralized maintenance authority. Field repair units operated close to the front, often only a few kilometers behind combat units. Mechanics worked outdoors, under time pressure, sometimes under direct threat. They welded cracked armor plates, bypassed damaged systems, reinforced broken components with scrap metal, and used substitute parts whenever possible. Manuals explicitly included field expedient solutions, acknowledging that ideal repairs were often impossible. Improvisation was not a failure of discipline, it was an expected skill. Responsibility for maintenance did not rest solely with specialists. Crews were trained to perform basic repairs themselves. Truck drivers learned engine troubleshooting. Tank crews learned to replace damaged components and keep vehicles running long enough to reach the next rally point. This distributed competence reduced bottlenecks and prevented small failures from cascading into operational losses. A damaged vehicle did not immediately leave the system. It remained useful until it could no longer contribute at all. Equally important was the American acceptance of loss. Vehicles were tools, not symbols. If a truck or tank could not be repaired quickly, it was abandoned or cannibalized without hesitation. Industrial capacity ensured that replacements would arrive. This removed the psychological pressure to preserve individual machines and shifted focus toward maintaining overall momentum. The system was built to absorb attrition rather than deny it. By late 1944, the advantages of this approach became increasingly visible. American units advanced with vehicles that would never have passed German inspection standards. Engines ran roughly, armor bore unrepaired damage, systems were bypassed rather than restored. Yet formations remained mobile, supply lines flowed, and operational tempo stayed high. What mattered was not mechanical elegance, but continuity. This doctrine transformed maintenance from a rear area function into a frontline enabler. Speed of repair became as important as firepower. A vehicle repaired overnight, even imperfectly, could influence the next day's battle. A vehicle awaiting perfect repair could not. The American system accepted inefficiency at the individual level to achieve efficiency at the operational level. In doing so, it quietly undermined the German belief that precision alone ensured superiority. The battlefield was beginning to reward adaptability over correctness, and momentum over control. As conditions worsened for Germany, this difference in doctrine would turn from an advantage into a decisive asymmetry. By late 1944, the battlefield no longer resembled the environment for which German maintenance doctrine had been designed. The war had accelerated beyond the assumptions embedded in precision-based systems. Retreat replaced advance. Improvisation replaced planning. Time, once a manageable variable, became a constant threat. Under these conditions, the German insistence on correct repair procedures began to collide directly with reality, and the consequences were immediate and compounding. Mechanical failure was no longer an isolated technical problem. It became an operational event. Vehicles broke down not in rear areas, but during withdrawals, under air attack, or along congested roads. Recovery vehicles were scarce. Fuel was limited. Workshops were overwhelmed or destroyed. Yet the doctrinal response remained largely unchanged. Damaged equipment was still withdrawn for proper repair, even when proper no longer existed. The system continued to ask for time that the battlefield could no longer give. As Allied pressure increased, the cost of delay grew exponentially. A tank immobilized for a transmission fault might once have been recovered and returned to service within days. In late 1944, the same fault meant abandonment. Not because the damage was severe, but because the doctrine governing repair could not compress itself to match the pace of events. Vehicles lined roadsides, technically repairable but strategically lost. Precision preserved machines in theory while surrendering them in practice. This collapse was most visible during large-scale retreats. German units attempting to disengage required mobility above all else. Yet precision maintenance doctrine prioritized restoration over continuity. Equipment that could have moved imperfectly was instead left behind, awaiting correct repair. Each abandoned vehicle further strained already limited resources, creating a feedback loop of scarcity. Cannibalization increased, but it remained reactive rather than systematic, eroding fleet strength without restoring operational balance. Meanwhile, Allied forces exploited this rigidity. Advances were timed to prevent recovery. Air-power targeted transport nodes and workshops, knowing that German repair systems were centralized and fragile. Every forced pause magnified German losses. A repair delayed by hours could become irrelevant by nightfall. A workshop overrun meant dozens of vehicles permanently removed from the order of battle. Precision, once a shield against failure, became a multiplier of it. The psychological impact was equally damaging. Crews watched machines they trusted become liabilities. Commanders planned around equipment that never returned. Confidence in systems eroded, but alternatives were unclear. Training had not prepared mechanics or crews to improvise at scale. Deviating from doctrine felt unsafe, even when adherence guaranteed loss. The system trapped its own operators, enforcing standards that no longer served their purpose. By contrast, Allied units treated breakdowns as expected friction. Vehicles damaged in combat were patched, not perfected. If they ran, they stayed. If they failed again, they were repaired again, or replaced. This resilience did not eliminate loss, but it controlled its effects. German precision doctrine, unable to accept degradation, experienced loss as sudden and absolute. The battlefield thus exposed a fundamental asymmetry. One system absorbed chaos and converted it into motion. The other attempted to resist chaos and fractured under its weight. Precision did not fail because it was technically flawed. It failed because it could not scale under collapse. War, in its final phase, no longer rewarded systems that required stability to function. By the end of 1944, the outcome was increasingly clear. The German maintenance doctrine was not being defeated by better engineering, but by a faster war. And once tempo replaced correctness as the decisive factor, the collapse of a precision-based system became unavoidable. By 1945, speed itself had become a form of firepower. The ability to move, repair, and advance faster than the enemy could respond reshaped the battlefield more decisively than incremental improvements in armor or weapons. American forces no longer treated momentum as a byproduct of success. It became a deliberate objective. Maintenance doctrine was now fully integrated into operational planning, ensuring that damaged equipment returned to service quickly, even if imperfectly, to sustain pressure without pause. Field repair units operated almost continuously. Vehicles damaged during the day were recovered, patched, and returned to columns overnight. Engines ran with reduced efficiency. Armor plates bore crude welds. Systems were rerouted or bypassed entirely. These machines were no longer examples of engineering elegance, but they remained operational. That operational presence mattered more than performance margins. A truck delivering fuel at half efficiency was infinitely more valuable than a perfect truck sitting behind the lines awaiting ideal repair conditions. Speed transformed the meaning of maintenance. Repair time became a tactical variable, not a technical one. Commanders calculated how quickly units could regain mobility rather than how thoroughly equipment could be restored. Decisions were made with hours in mind, not days. This compressed timeline denied German forces the ability to stabilize, reorganize, or recover abandoned equipment. Even small delays became decisive when layered across entire formations. The German system struggled to respond. Precision-based maintenance required predictable schedules, secure locations, and access to specialized resources. Speed denied all three. Workshops were forced to relocate repeatedly, losing tools and parts in the process. Skilled technicians were dispersed, captured, or reassigned. The system fractured into isolated pockets, unable to support one another. Attempts to decentralize came too late, constrained by training and institutional habits that favored control over adaptability. Allied speed also altered enemy decision-making. German commanders increasingly abandoned equipment preemptively, knowing that repair timelines could not match Allied advances. This self-reinforcing cycle accelerated collapse. Mobility was lost not only through destruction, but through anticipation of inability to recover. Speed imposed psychological pressure that precision doctrine was never designed to absorb. Importantly, American doctrine did not equate speed with recklessness. Improvisation followed guidelines. Field expedient repairs were documented, taught, and standardized where possible. The system balanced flexibility with coherence, ensuring that rapid repair did not devolve into chaos. This balance allowed speed to scale across entire armies rather than remain a local advantage. As momentum increased, German precision engineering lost its strategic relevance. Superior tolerances, advanced designs, and careful workmanship could not compensate for absence from the battlefield. A machine that could not move might as well not exist. Speed redefined value in purely operational terms. By early 1945, the outcome was no longer in doubt. The side that could repair fastest dictated the rhythm of the war. Speed had become a weapon in its own right, one that bypassed armor, outpaced doctrine, and rendered technical superiority meaningless if it could not keep up. Military doctrines rarely collapse because they are fundamentally wrong. They collapse because the environment changes faster than the doctrine can adapt. German precision maintenance doctrine followed this pattern exactly. It was not defeated by inferior engineering or poor workmanship, but by a battlefield that no longer allowed the conditions under which precision could function. By late 1944 and early 1945, the gap between doctrine and reality had become unbridgeable. German maintenance philosophy assumed stability, predictable rear areas, scheduled repair cycles, and access to trained specialists. As these assumptions failed, the doctrine did not evolve quickly enough to replace them. Attempts were made to simplify procedures and decentralize repairs, but they were constrained by years of institutional training. Mechanics had been taught to restore machines correctly, not quickly. Command structures were designed to control maintenance, not to distribute it. Changing this mindset in the final months of a collapsing war proved impossible. Industrial strain compounded the problem. Allied bombing disrupted factories, transport hubs, and supply depots, making the delivery of exact spare parts increasingly unreliable. Precision systems, dependent on specific components, suffered disproportionately. A missing part could immobilize a vehicle entirely. In contrast, Allied systems substituted, bypassed, or adapted. German doctrine treated substitution as unacceptable risk. The result was paralysis, not protection. As losses mounted, precision maintenance created an illusion of preservation. Vehicles were withdrawn from combat to be saved, but the time required to save them exceeded the time available. Equipment pools shrank not because machines were destroyed, but because doctrine removed them from the battlefield faster than it could return them. The system protected technical standards at the expense of operational strength. What remained was correctness without presence. This failure was also cultural. Precision had become intertwined with identity. German engineering superiority was not just practical, it was symbolic. Letting standards slip felt like surrendering that identity. As a result, adaptation was resisted, even when necessity demanded it. Doctrine hardened under pressure instead of flexing. The more chaotic the battlefield became, the more rigid the system responded, accelerating its own failure. Commanders increasingly faced impossible choices. They could adhere to doctrine and lose mobility, or violate doctrine and risk unsafe or unreliable equipment. Many chose adherence, not out of stubbornness, but because alternatives had never been legitimized. Improvisation without institutional support felt dangerous, even reckless. The doctrine offered certainty in procedure, but not survival in outcome. By early 1945, the collapse was systemic. Maintenance timelines no longer aligned with operational needs. Workshops became irrelevant. Skilled technicians were underutilized because the systems they supported no longer existed. Precision maintenance, once a pillar of German military power, had lost its strategic purpose. The doctrine did not fail quietly. It failed visibly, leaving behind columns of repairable but abandoned machines, symbols of a system that valued correctness over continuity. When war demanded speed, a doctrine built on control could only fall behind. When the war finally ended, the silence revealed what the noise of battle had obscured. Along roads, in forests, and at the edges of ruined towns, German vehicles sat abandoned. Not because they were destroyed, but because doctrine had left them behind. These machines represented more than material loss. They were the physical remains of a belief system that had stopped matching reality. Precision had protected standards, procedures, and identity, but it had failed to protect momentum. And when time became the dominant force of the battlefield, momentum decided everything. The outcome of the war did not invalidate precision itself. What it invalidated was the assumption that precision could survive unchanged in a collapsing environment. The American system did not win because it rejected quality, but because it understood when quality must yield to continuity. Speed did not replace engineering excellence. It determined whether engineering excellence could still influence events. The battlefield no longer rewarded the best designed machine. It rewarded the system that could keep machines moving, repairing, adapting, and returning to action faster than the situation evolved. This realization reshaped military thinking after 1945. Modern forces prioritize modularity, rapid replacement, decentralized repair, and resilience under degradation. The objective is no longer perfection in isolation, but sustained capability under pressure. The war proved that systems built for ideal conditions struggle when control disappears, while systems designed for friction grow stronger the more chaotic the environment becomes. And this lesson reaches far beyond military history. Here is the deeper takeaway, and why it still matters today. In real life, stability is rare. Markets change, careers accelerate, technology shifts, and personal circumstances evolve faster than plans can keep up. Yet many people and organizations still operate as if conditions will remain predictable. They wait until everything is perfect before acting. They delay decisions until uncertainty is eliminated. They refine endlessly, assuming time will always be available. Just like German maintenance doctrine, this approach feels safe, but only while the environment remains stable. Speed, in this context, does not mean rushing blindly. It means responding while conditions still allow influence. Progress favors those who move early, learn fast, and adjust continuously. A plan that works imperfectly today often beats a perfect plan that arrives too late. Momentum creates options. Delay removes them. The American maintenance mindset succeeded because it treated error as inevitable and built systems that could recover quickly. The German mindset failed because it treated error as unacceptable and built systems that froze when it appeared. Applied to everyday life, this means understanding when good enough is not compromise, but strategy. Careers advance when people act before they feel fully ready. Businesses survive when leaders prioritize adaptability over flawless execution. Creative projects succeed when they are released, tested, and improved, not endlessly refined in isolation. Perfection has value, but only when it serves forward movement rather than replacing it. The most resilient individuals and organizations are not those who avoid mistakes, but those who recover from them fastest. They design their systems, habits, and decisions around reality, not ideals. They accept friction, uncertainty, and failure as part of motion. Like wartime logistics, life rewards continuity more than correctness. That is the enduring lesson of this story. Precision is powerful, but only when it supports momentum. When conditions accelerate, the question changes. It is no longer, is this perfect? It becomes, does this keep us moving? So here is a simple question for you. When things start moving fast, what matters more to you? A. Doing it perfectly. B. Doing it fast and adapting along the way. Please leave a comment below with A or B and briefly explain your reasoning. Your perspective may help others see this lesson from a different angle. If you value deep, thoughtful stories like this, stories that connect World War II to lessons we still live with today, please consider subscribing to W2 Forgotten Fronts. Your support gives the channel the motivation to continue uncovering overlooked histories and turning them into insights that still matter.